So with rational functions, we're basically going to now that we have them defined, is we're going to basically look at some new graphical features, things that we haven't really seen before in graphs, although I've kind of snuck them at you from time to time, but we're going to officially define them and learn how to find them, etc., etc. So first, let's start off with the definition. What we have are these things called vertical asymptotes. These are basically vertical lines. So recall, to get a vertical line, I let x equal a number. And what happens is the graph, as we approach, the graph actually approaches positive or negative infinity as inputs get closer to c. And mathematically, what we say is that as x approaches c, so as my inputs get closer and closer to the c value, the outputs, and I'm going to go ahead and use the absolute value because, again, it can go positive or negative, but absolute value-wise, this means we're unbounded. So the graph is unbounded right around where x equals to c. And again, visually what's happening here is, let's just say we have a little graph here, and there's my c value. And so as my inputs get closer and closer to c, so as my x's get closer and closer and I evaluate the function at those values, the outputs are either going to positive infinity or they're going to negative infinity right around that vertical line, And of course, the same thing's happening on the other side. As my x values get closer and closer to c, my outputs are either going to positive infinity or going to negative infinity. So there's basically like a ripping apart of the graph. It's undefined. It's division by zero, as we've seen before, and impacted domain is undefined. So that's basically what's happening. Another thing that will happen, or will never happen, is we will never cross a vertical asymptote graphically. And that's because, again, we're undefined. F of c, right, causes a division by zero, and that's an undefined situation. So we will never have an output, right, when we have that c value where this is occurring. So there's the theory, there's the definition, and it turns out there's some good news here for us, because the work we did with regard to finding our domain, it turns out, since those are the values that cause zero that we threw out of the domain, those are the areas where a potential vertical asymptote is going to occur. So we've already done the work just by finding the domain. We've basically found some of those potential x equals c's where this is going to happen. So let's go ahead and let's turn to our technology to kind of see this in action now that we have the definition. And let me go ahead and warn you guys, my TI calculator, I think there must be something wrong with it in terms of a short or whatever, but what I've gone, this is Desmos. It's on my graphing calculator. Pretty good tool. So one of the first ones we did was 2x minus 2 over x plus 3. And what we found right earlier is that the domain, right, the division by 0 occurs at negative 3. So we're defined for everything to the left of negative 3 and everything to the right. So when I go graph this, let me go ahead and change that input. I think I put it in wrong. 2x minus 2 all over x plus 3. So when I go graph this, let me turn that function on. There's the graph. And let me zoom out a little bit. And you can basically see that at negative 3, right, so that's where that value's at. So let me so there's negative 2. So negative 3 is right about there. All right, there's negative 3. And you can see as I zoom out of that area, the graph, right, is literally ripping itself apart. So as we approach negative 3 from this side, the outputs are going towards negative infinity. When we approach negative 3 from this side, the outputs are going to positive infinity. So that's kind of what that definition is saying. So absolute value-wise, our outputs are getting huge as our inputs get closer and closer to that c value. And there's a classic x equals to negative 3, right, would be that vertical line where that's happening. For the next one, what we found, the 0 is occurring at negative 2. And so what I expect to see is a vertical asymptote there. So let me turn that guy off and turn this one on. And sure enough, right, let me zoom in a little bit. Right, there's negative 2. And as we zoom around out there, right, you can see that the graph is ripping itself apart. So as we approach negative 2 from this side, we go to negative infinity. When we approach negative 2 from this side, we go to positive infinity. So the graph, again, is ripping itself apart at that location. For the next one, what we have, right, is we found there's actually two values that make the denominator 0, right, plus and minus 5. So what I expect to see out of this graph when I turn to the technology is I would expect to see two vertical asymptotes, one occurring at -5 and the other one occurring at +5, and that's exactly what we see. Let me zoom in a little bit. So yeah, so there's -5 and there's 5, and you can see again the graph is ripping itself apart at those values. As I approach -5 from this direction, the outputs are going to -infinity. As I approach -5 from this direction, the outputs are going to +infinity. And over here at 5, it's kind of the opposite. So as I approach 5 from this side, the outputs are going to -infinity. As I approach my inputs approach 5 from this direction, the outputs are going to +infinity. So the graph again is ripping itself apart, if you would, around those vertical lines, -5 and 5. And then last but not least, if you're not convinced, right, where we had the last one, we had a 0 at 2. And so we expect a vertical asymptote that ripping itself apart, if you would, at that value. And so when I go graph that, let me make sure I have the right graph, right? So when I turn that on, sure enough, right, let me zoom in a little bit. There's 2, and you can see the behavior is actually as we approach 2 from either direction, from the left or the right, as my inputs go to 2 in either direction, the outputs are going to +infinity in both directions, right? So there's a thing going on there, and we'll discuss why that's happening later on in this module, right? But for now, what we have again is the idea that wherever I have, so when we find the domain, if you would, doing kind of an old question, what we are also doing is potentially, and I want to reemphasize the word possible, as you'll see in a moment, right? We find possible locations where we have a vertical asymptote, x equals c, where again the graph, by definition, is ripping itself apart. Okay, as our inputs get closer to c, the outputs are unbounded. They're going towards positive or negative infinity, depending on the function itself. All right, so that's one of the first new graphical features of a rational function, that there's a very high possibility, because of the division by zeros, that our graphs will have vertical asymptotes. All right, more coming soon.